Welcome back to QHSE Talks. Imagine an operator at a chemical plant, right? And they are running behind schedule. It's the very end of a brutal 12-hour shift. The lighting is poor, and they just mistakenly connect a transfer hose.
Oh man, that is a classic setup for disaster.
Right, so they end up pumping like a few hundred gallons of chemical X into a massive storage vat of chemical Y. Now, for you listening, here's the million-dollar question. Does that mistake just create some minor bubbling fizz that requires a mop, or does it trigger a massive exothermic reaction that levels a 3-block radius and shatters windows a mile away?
Yeah, and in the world of highly hazardous chemicals, not knowing the answer to that isn't just an administrative oversight. I mean, it is a literal catastrophe waiting to happen.
Exactly. And that is why today we are bringing you a hyper-focused masterclass. If you are a safety professional preparing for the ASP 11 Domain 2 Topic 8 Part H exam, you are going to want to eliminate all distractions right now. We are zeroing in specifically on process safety.
Which is such a critical topic.
It really is. For you, the listener, navigating the complexities of your duties in the field, and yes, passing that crucial exam, this is the foundational life and death knowledge you absolutely need.
Yeah, because that scenario you just painted, that is exactly what keeps process safety engineers awake at night.
Oh, I bet.
When we talk about process safety, we are talking about a very specific, high-stakes realm of risk. We aren't discussing, the general industry hazards of slips, trips, and falls here.
Right, as important as those are.
Right, they matter. But Process Safety Management, or PSM, is fundamentally aimed at preventing the catastrophic releases of highly hazardous chemicals. We're talking toxic, reactive, flammable, or explosive substances.
Big stuff.
Exactly. And to put cage around that kind of risk, we rely heavily on the OSHA 29 CFR 1910.119 Process Safety Management Standard. So it's a 14-element framework that provides the legal authority, the structural blueprint, and the operational rigor to keep facilities from experiencing those, leveling a 3-block radius types of failures.
Yeah, and before we get into the weeds on that, I want to give a quick teaser for you listeners out there. While today is strictly about mastering those 14 elements of the OSHA framework, we are going to have a future QHSE talks focusing on the expanded 20-element framework.
Ah, the CCPS one.
Yep, the one developed by the Center for Chemical Process Safety. The CCPS framework takes these foundational OSHA legal elements and broadens them even further into what we call risk-based process safety.
Which is fascinating in its own right.
It is, but for now, our mandate is entirely on these 14 OSHA elements. You need this to pass the exam, and frankly, you need this to ensure everyone goes home safe at the end of their shift.
100%.
Okay, let's unpack this. We have to start at the absolute foundation. We have to look at the people involved, specifically OSHA's Element 1, which is employee participation, found under 1910.111C.
Right. So the legal requirement for Element 1 is that employers must develop a written plan of action regarding the implementation of employee participation.
Written plan of action. Got it.
Yes. Employers are legally mandated to consult with employees and their representatives on the conduct and development of process hazard analyses, or PHAs, and on the development of the other elements of process safety management.
Wait, all the other elements too?
All of them. Furthermore, they must provide employees access to those PHAs and to all other information required to be developed under this standard.
Let me stop you right there, because I know how exam prep works. It is incredibly easy for people studying to gloss over this as just, standard bureaucratic HR speak.
Oh yeah, people skip right over it.
But if I'm interpreting this correctly, this isn't just about putting up a suggestion box in the break room and calling it a day, is it? We are talking about mandatory systemic consultation.
Exactly. It's not a suggestion box.
But realistically, if I'm building a highly technical process hazard analysis, wouldn't it be faster and more efficient to just lock a bunch of chemical engineers in a boardroom and let them design the safety protocols?
Yeah.
Why force the inclusion of operators?
I mean, it might be faster, sure, but it would be fatally flawed. Yeah. What's fascinating here is the underlying philosophy of the regulation. Why start with the employees? Because the people out there turning the physical valves, monitoring the analog gauges, and walking the pipelines at 2 a.m, they have the most direct, granular knowledge of how the process actually behaves.
That makes sense.
Top-down safety programs almost always fail without bottom-up reality checks. Like, an engineer might have designed a system to operate a certain way on a pristine AutoCAD drawing.
Right, in a perfect world.
But the operator knows that in the dead of winter, valve 4B gets sticky, freezes up, and needs a specific touch or a steam lance to open.
Oh, wow.
Yeah. If you don't include that operator's grand truth knowledge in your hazard analysis, your risk assessment is based on a fantasy version of your plant, not the real one.
That makes total sense. You need the boots on the ground to tell you what the blueprint actually looks like in reality, because the map is not the territory. So if the operators are the ones telling you that a specific valve gets sticky in the winter, you need a master blueprint to understand what's actually flowing through that valve, what the pressures are, and what the chemical risks are. Which means OSHA mandates that blueprint through Process Safety Information, or PSI.
Yes, element 2.
Right, which brings us to element 2 under 1910.119D. I like to think of PSI as the biological DNA of the facility. Before you can even attempt to analyze a hazard, you need to know exactly what elements make up the organism.
A facility's DNA is a great way to look at it. But OSHA requires that DNA to be sequenced into 3 extremely specific mandatory buckets.
Okay, what are the buckets? Because if you are preparing for the exam, you need to know these inside and out.
You really do. The first bucket is the hazards of the chemicals themselves.
Okay.
The second is the technology of the process. And the third is the equipment in the process.
Let's dig into that first bucket, hazards of the chemicals. We are dealing with highly hazardous materials, so what specific data points is OSHA demanding a facility keep on file?
OSHA requires a comprehensive, exhaustive profile. I mean, you must compile information on toxicity, permissible exposure limits, or PALs, physical data, reactivity data, and corrosivity data.
That is a lot of data.
It doesn't stop there. You also need thermal and chemical stability data. And crucially, you must document the hazardous effects of the inadvertent mixing of different materials that could foreseeably occur.
Which brings us right back to my opening scenario. The operator accidentally pumps chemical X into chemical Y. The facility needs to have already documented in writing whether that creates a minor fizz or a massive exothermic reaction.
Exactly. They have to know that beforehand.
But gathering all that data sounds like a monumental task. Do companies have to, hire a fleet of chemists to run original experiments on every substance they buy?
Well, not necessarily. The standard does offer a practical lifeline here. Safety data sheets, or SDS, meeting the requirements of the OSHA Hazard Communication Standard at 29 CFR 1910.12/0G can be used to comply with this requirement.
Oh, good. That makes it easier.
But, and this is a massive but, they can only be used provided they actually contain all the specific information I just listed.
Ah, catch.
Big catch. If an SDS from a supplier is vague about thermal stability, the employer is still on the hook to find and document that specific data. You can't just shove a binder of incomplete SDSs on a shelf and claim compliance.
Okay, so that is bucket 1. The chemicals. Bucket 2 is the technology of the process. Now, when I hear technology, I immediately think of software, servers, or maybe the digital control systems, but I am assuming this isn't about the IT department.
Yeah, not at all.
So what does technology mean in the context of chemical manufacturing?
In process safety, the technology refers to the core chemistry, the physics, and the flow of the manufacturing process itself. The standard explicitly requires a block flow diagram or a simplified process flow diagram.
So like a visual map of the process.
Yeah. It also requires the process chemistry, the maximum intended inventory of chemicals on site, and the safe upper and lower limits for parameters like temperatures, pressures, flows, or compositions.
Okay, limits are crucial.
Right. And finally, it requires an evaluation of the consequences of deviations.
Wait, what does that mean exactly?
It means if the temperature in a reactor exceeds the safe upper limit of 400 degrees Fahrenheit, what happens?
Right.
Does the product just scorch and ruin the batch? Or does the vessel overpressurize and detonate?
Right.
The facility must know and document that answer.
So it is the theoretical model and the operational boundaries of how the plant is supposed to run, which brings us to the third bucket, the equipment in the process, the physical hardware that actually contains the chemical reactions.
And this list is extensive, let me tell you.
I'm ready.
You need to document the materials of construction. For instance, what specific grade of steel are those pipes made of, and is it compatible with highly corrosive acids?
Right, you don't want the acid eating right through it.
Exactly. You need piping and instrument diagrams, commonly known in the industry as P&IDs.
P&IDs, yeah.
You need electrical classifications, relief system design and design bases, ventilation system designs, design codes and standards employed, and the material and energy balances for processes built after May 26, 1992.
That is incredibly specific.
It is. You also must extensively document the safety systems, which includes interlocks, detection sensors, or suppression systems.
Okay, I have a major question here, and I want to play devil's advocate for a second.
Right for it.
I'm putting myself in the shoes of a safety manager at a legacy chemical plant that was built in, say, the 1960s. You are telling me I need all this documentation based on modern design codes.
Right.
What if I am dealing with ancient equipment built decades ago, long before modern codes, standards, or even OSHA itself were established? Are these legacy plants just out of compliance by default? Do they have to shut down?
That is a very common concern in the field, actually. But OSHA recognizes that you can't just bulldoze every chemical plant built before 1990 and start from scratch.
Okay, so what is the workaround?
For existing equipment that was designed and constructed in accordance with codes, standards, or practices that are no longer in general use, the employer must determine and document that the equipment is designed, maintained, inspected, tested, and operating in a safe manner.
And how do they prove that?
They do this by adhering to what we call RAGAJAFE.
RAGAJ. That is a critical acronym for you listeners. It stands for Recognized and Generally Accepted Good Engineering Practices.
It is the absolute bedrock of maintaining older facilities. You have to prove, document, and mathematically defend that even though a pressure vessel is 50 years old and built to an obsolete standard, you are applying rigorous modern engineering principles.
Like what?
Like ultrasonic thickness testing and calculated corrosion rates, just to ensure it is still safe to operate today. You can't just say, well, it hasn't blown up yet, so it must be fine.
Yeah, that's not going to fly with an auditor. So you have the people involved from Element 1, and you have meticulously mapped out the DNA and blueprint of the entire facility in Element 2. Once you have that perfect theoretical model, you have to start actively trying to break it to find its hidden weaknesses. Which leads us perfectly to Element 3 of the standard. Process Hazard Analysis, or PHA, under 1910.111E.
Element 3 is arguably the beating heart of the entire PSM standard.
The beating heart, I like that.
A process hazard analysis is a thorough, orderly, systematic approach for identifying, evaluating, and controlling the hazards of processes involving highly hazardous chemicals.
That sounds huge.
It is a massive undertaking. And because it's so resource intensive, you can't just tackle every system in a massive refinery at once. Employers must determine a priority order for conducting these analyses.
But how do they prioritize? By whatever system is geographically closest to the plant manager's office so they don't have to walk as far? Or, whatever's cheapest to analyze?
No. It has to be driven by risk, not convenience.
Sure.
The rationale for prioritization must include considerations like the extent of the process hazards, the number of potentially affected employees, the age of the process, and the operating history of the process.
So history matters.
Oh, absolutely. If a specific cracking unit has a history of leaks and near misses, and it holds a massive inventory of toxic hydrogen sulfide gas, it legally goes to the top of the list for analysis.
Okay. Now, for the exam, I know they love testing on the specific methodologies required by OSHA. You just mentioned this has to be a systematic approach.
Yes, very systematic.
That means you can't just gather a few engineers around a conference table with a box of donuts and brainstorm what might go wrong. The standard lists several required methodologies, right? Like what if checklist, hazard and operability study, which most people call HAZOP failure mode and effects analysis, or FMEA, and fault tree analysis.
That's the list.
Why all the different acronyms? Do they all basically do the same thing?
They absolutely do not. And understanding a difference is key for the exam in real life. They are distinct tools designed to prevent cognitive blind spots. Let's break a few down.
Please do.
A HAZOP, for instance, is highly structured. You look at a specific node on a P&ID and apply guide words.
Guide words.
Yeah, you ask, what happens if there is more flow? What if there is less temperature? What if the flow goes in reverse? You systematically force the team to evaluate deviations from the design intent.
Okay, that makes sense. What about FMEA?
An FMEA, on the other hand, is component-focused. You look at a specific pump and ask, what are all the ways this pump can fail? And what is the effect of each failure?
Oh, I see. So HAZOP is process flow, FMEA is the physical piece of equipment.
Exactly. And then fault tree analysis is deductive and works backward. You start with a hypothetical catastrophic event, like a tank explosion, and you map out every single logical pathway and failure combination that could lead to that top event.
I always like to think of a PHA team, especially when doing it HAZOP, like a group of obsessive, nitpicking movie critics trying to find plot holes in a script.
That's actually a great way to put it.
They are looking at the script, which is the facility's P&IDs, and they are systematically going through every single node, Every single scene, they are relentlessly trying to break the narrative to see where the catastrophic ending is hidden. If valve A fails open while pump B is running, does the story end in an explosion?
That is a perfect analogy.
Yeah.
And while they are hunting for those plot holes, OSHA is very strict about what the PHA must specifically address.
Right, they have a checklist of requirements.
They do. It's not just a general safety assessment. The PHA must address the hazards of the process itself. And crucially, it requires the identification of any previous incident which had a likely potential for catastrophic consequences in the workplace.
Oh, so if a facility had a near miss 3 years ago where a reactor almost overpressurized but an operator caught it at the last second, your PHA legally must address that specific historical scenario to ensure it can't happen again.
Precisely. You can't ignore the past. The PHA also must address engineering and administrative controls applicable to the hazards like specific detection methods, automated interlocks, or alarms. And it has to address the consequences of failure of those controls. Furthermore, it must evaluate facility siting.
Facility siting, meaning where buildings and people are physically located on the property.
Yes.
Why is that part of a process hazard analysis?
Because if a vessel ruptures, geography matters. Are your control room operators sitting in unreinforced temporary wooden trailers located 50 feet from a volatile distillation column?
Oh, wow. Yeah, that would be bad.
Right. The PHA must evaluate whether the physical location of personnel exposes them to unacceptable risk from fire, explosion, or toxic release. It also must evaluate human factors.
Human factors, so the psychology and ergonomics of the operators.
Yes, exactly that.
Yeah.
Are the critical emergency valves labeled clearly, or are they rusted over? Does an operator have to reach over an uninsulated 300-degree steam pipe to turn a critical dial?
Yikes.
Yeah, or are the alarms in the control room so frequent that operators suffer from alarm fatigue and just start ignoring them?
Oh, alarm fatigue is a huge issue.
It is. The PHA has to look at the human-machine interface. And lastly, the PHA requires a qualitative evaluation of a range of the possible safety and health effects of failure of controls on employees in the workplace.
This sounds incredibly rigorous and, frankly, exhausting. You definitely can't just have a single safety manager knock this out in their office on a Friday afternoon to satisfy an auditor.
No, it's literally impossible for one person to do it correctly. The standard strictly dictates the team composition.
Really? Who has to be on it?
The PHA must be performed by a team with expertise in engineering and process operations. And here is where it ties directly back to element 1.
Employee participation.
Exactly. The team must include at least one employee who has direct experience and knowledge specific to the process being evaluated. And finally, at least one member of the team must be knowledgeable in the specific PHA methodology being used.
So you need a designated, trained HAOP facilitator to guide the room, not just a manager who read a pamphlet about it on the flight over.
Precisely.
And once you finish this massive analysis, which I imagine could take weeks or even months, and you generate hundreds of recommendations, it's not just a binder that sits on a shelf to gather dust, right?
Right. This is not a one-and-done, check-the-box deal.
Yeah.
The standard requires that PHAs must be updated and revalidated at least every 5 years by a qualified team.
Okay, every 5 years. That's a good exam now.
Yes, to assure that the PHA is consistent with the current process.
Yeah.
And you must retain the PHAs and the documented resolution of all those recommendations for the entire life of the process.
Wow. For the entire life of the process. Okay, so the PHA tells us everything that can possibly go wrong in the facility. It identifies the hazards, the failure points, and the necessary controls.
Right.
But identifying the risk isn't the same as operating the plant safely day to day. If the PHA is the list of plot holes, element 4 tells us how to actually act out the script so we survive the movie. Let's look at element 4. Operating procedures, found under 1910.119F.
Okay, so for element 4, the employer must develop and implement written operating procedures that provide clear instructions for safely conducting activities involved in each covered process.
Written procedures.
Yes, and importantly, these procedures must be consistent with the process safety information, the DNA, that we talked about back in element 2.
You know, when I first got into this field, I thought an operating procedure was just like a laminated sheet telling you how to turn the machine on and off.
Oh, it is so much more than that.
The OSHA standard requires procedures for every single operating phase, doesn't it?
The level of detail required is just exhaustive. The procedures must cover steps for initial startup, normal operations, temporary operations, and emergency shutdown.
Emergency shutdown has to be documented step by step.
Absolutely. For emergency shutdown, it must explicitly specify the conditions requiring the shutdown and the assignment of shutdown responsibility to qualified operators to ensure it happens safely and in a timely manner.
That is so critical.
It also must cover emergency operations, normal shutdown, and startup following a turnaround or startup after an emergency shutdown.
Think about the psychology of that for a second. An emergency shutdown is chaotic by nature. Alarms are blaring, lights are flashing, people are stressed out of their minds.
Panic is a real factor.
Right. If you don't have a written procedure assigning exact responsibilities, meaning Operator A's only job is to hit the kill switch, while Operator B's only job is to open the vent valve to relieve pressure, you have panic.
And panic in a chemical plant leads to disasters.
The source material provided an incredible, albeit tragic, example of why these procedures need to be rigorously controlled documents.
Oh, the fired heater case?
Yes. There was a historical case where an operator was charged with lighting a fired heater at a refinery. He was tragically killed when the heater exploded at startup. Why? Because the operator had followed a purge procedure that was literally painted on the wall near the heater.
That case raises an incredibly important point about document control and the reality of field operations.
It's chilling.
It is. The procedure painted on the wall was out of date. It did not include some newly added critical steps that were contained in the actual updated manual sitting safely in the control room.
He had no idea.
Right. The operator followed the only instructions he had in front of him, and it cost him his life. This is a visceral illustration of why OSHA is so strict about this element. Procedures must also cover operating limits, meaning the consequences of deviation and the steps required to correct or avoid deviation.
Which goes back to the PHA findings.
Exactly. They must detail safety and health considerations, the properties and hazards of the chemicals, the precautions necessary to prevent exposure, like specific PPE and engineering controls and quality control for raw materials.
And to prevent the painted on the wall scenario where obsolete procedures are lingering in the field, the employer has to actively manage these documents. They have to certify these procedures, right?
Yes, they do. They must certify annually that these operating procedures are current and accurate. Annually. You have to physically verify that the document in the operator's hand matches the reality of the plant.
Okay, good.
Furthermore, the employer must develop and implement safe work practices to provide for the control of hazards during operations. This includes critical, life-saving practices like lockout-tagout, confined space entry, opening process equipment or piping, and control over entrance into a facility by maintenance, contractor, laboratory, or other support personnel.
Which applies to both internal employees and contractors. Now, having a perfectly written, annually certified procedure in a pristine binder doesn't mean a thing if the operator holding it doesn't understand what it says.
That's the truth.
Which bridges us seamlessly to Element 5, training, under 1910.119G.
Right, because having the playbook is useless if the team doesn't know the plays. Initial training must be provided to each employee presently involved in operating a process, and to each employee before being involved in operating a newly assigned process.
What does that training have to cover?
This training must cover an overview of the process and the specific operating procedures we just discussed. It has to emphasize specific safety and health hazards, emergency operations including shutdown, and safe work practices applicable to the employee's job tasks.
Here's where it gets really interesting. Training under PSM isn't just a box-checking exercise. You can't just herd 50 operators into a hot break room, play a faded safety VHS tape from 1995, have them sign an attendance sheet, and legally claim they are trained.
No, you definitely cannot do that. The standard is explicitly looking for performance assurance.
That is a critical distinction, performance assurance.
The employer must verify understanding. Refresher training must be provided at least every 3 years, or more often if necessary, to each employee involved in operating a process to assure that the employee understands and adheres to the current operating procedures.
Wait, so the employer actually has to test them?
Yes. The employer has to ascertain that each employee involved in operating a process has received and understood the training. They have to prepare a record containing the identity of the employee, the date of training, and the means used to verify that the employee understood the training.
Let's focus on that phrase. Means used to verify that the employee understood. That means you can't just rely on a signature on an attendance log.
A signature proves they were in the room. It doesn't prove they learned anything.
Right. You need written testing, practical demonstrations in the field, targeted toolbox talks. It requires constant reinforcement. If an OSHA inspector walks in, they want to see the test scores or the supervisor sign off on a practical field demonstration.
It is the only legally and practically sound way to ensure the playbook is actually being executed on the field, especially during an emergency.
Okay, this brings us to a massive vulnerability that every safety professional listening to this knows all too well. We've talked about our own people, our own procedures, our own training, but plants don't operate in a vacuum. Let's talk about element 6, contractors, found at 1910.1192.
Oh, contractors. They represent a unique and significant vulnerability in any process facility.
Why is that? Just because they are new to the site?
Because by their very nature, they are transient. They are often brought in for specialized maintenance, turnarounds, or capital projects. They might not know the facility's DNA, the PSI, or the playbook, the operating procedures, as well as the internal staff who walk those pipes every day.
That makes total sense.
Yet they're coming in to do a specific job that inherently involves interacting with and potentially compromising the process equipment.
So how does OSHA mandate a facility handle them? Can a plant owner just hire a scaffolding company and wash their hands of any liability if something goes wrong? Like, hey, they don't work for me?
Absolutely not. The employer must apply safe work practices to control the entrance, presence, and exit of contract employers and contract employees in covered process areas. But the responsibility starts even before the contractor arrives on site.
Really, during the bidding process?
Yes. The employer must obtain and evaluate information regarding the contract employer's safety performance and programs. You can't just hire the cheapest contractor bidding on a job if their safety record is abysmal. You have to vet their total recordable incident rate and their experience modification rate.
That's huge. And once they pass the vetting process and actually arrive on site, the facility owner still has heavy responsibilities toward them.
They do. The employer must inform contract employers of the known potential fire, explosion, or toxic release hazards related to the contractor's work in the process.
You have to warn them.
Yes, and they must explain the applicable provisions of the facility's emergency action plan. If the siren sounds, the contractor needs to know exactly which muster point to run to.
They can't just be wandering around during an emergency.
Right. The facility owner must also periodically evaluate the performance of contract employers in fulfilling their obligations. And interestingly, the host employer must maintain a contract employee injury and illness log specifically related to the contractor's work in process areas.
I want to highlight that last point for anyone taking the ASP exam. You have to track contractor injuries that occur in the process areas, separate from your general OSHA 300 log for your own direct employees.
Yes, it's a specific requirement.
It legally forces the facility owner to take absolute ownership of the safety culture of everyone inside the fence line, regardless of whose logo is on their hard hat.
It completely removes the "they don't work for me" excuse.
Okay, let's transition to another incredibly high-risk moment in a facility's life cycle, starting up a process. Whether it's a brand new plant or restarting after a major modification, this introduces immense risk. This is governed by Element 7, Pre-Startup Safety Review, or PSSR, under 1910.111I.
PSSRs are so critical.
I love the analogy of the PSSR acting as a commercial airline pilot's strict pre-flight checklist. A pilot doesn't just kick the tires, hop in the cockpit, and hit the throttle to maximum thrust.
Let's hope not.
They methodically check every single system, hydraulics, flaps, communications, before they introduce the real danger. In an aircraft, the danger is gravity. In a chemical plant, the danger is introducing highly hazardous chemicals into the system.
That's a great comparison. A PSSR applies to both new facilities and modified facilities when the modification is significant enough to require a change in the process safety information.
Yeah.
Before any highly hazardous chemical is introduced to a process, the PSSR must confirm 4 mandatory things.
For you listening, if you are driving, make a mental note. If you are at a desk, write these 4 down. They are prime exam material.
Okay, number 1, construction and equipment must be in accordance with design specifications. If the engineering drawing said to use highly specialized stainless steel piping to resist acid, the PSSR physically confirms it's actually stainless steel installed in the field, not cheaper carbon steel that a contractor swapped in to save a buck.
Got it. What's number 2?
Number 2, safety, operating, maintenance, and emergency procedures are in place and are adequate.
Check. Number 3.
Number 3, for new facilities, a process hazard analysis has been performed and recommendations have been resolved or implemented before startup. For modified facilities, they must meet the requirements contained in Management of Change.
Okay, and the last one?
And number 4, training of each employee involved in operating a process has been completed.
If we look at the narrative connection of the OSHA standard here, the PSSR is the ultimate safety net. It is literally checking that Element 2 process safety information, Element 3 process hazard analysis, Element 4 operating procedures, and Element 5 training have all been successfully completed before the real danger is introduced.
It's the final gatekeeper before you open the main feed valve.
Yeah.
That is the perfect synthesis of its function. It ensures all the preceding theoretical paperwork actually translated into physical reality and workforce readiness.
Okay, so let's assume the plan is built correctly, the contractors are managed safely, the procedures are flawless and trained on, the PSSR is signed off, and the plant is running smoothly. We are making product and generating revenue.
The dream state.
Right. Now we have to keep the beast tamed. You know, the biggest enemy of a chemical plant isn't necessarily a sudden dramatic accident or an earthquake. It's entropy. Things vibrate loose over time. Pipes rust from the inside out. Seals degrade under constant heat.
Entropy is relentless.
How does OSHA mandate we fight entropy?
We fight the slow degradation of the facility with Element 8, mechanical integrity, found at 1910.119J. It is not enough to design a theoretically safe plant. You must maintain it in a safe condition over a lifespan that could stretch for decades.
Does this apply to everything, like the coffee maker in the break room?
No, the scope of this element is highly specific. It applies to pressure vessels and storage tanks, piping systems including valves, relief and vent systems and devices, emergency shutdown systems, controls, which includes monitoring devices, sensors, alarms, and interlocks, and finally, pumps.
So practically everything that contains, moves, or controls the hazardous chemicals. But let me push back on this. Maintenance costs money, and shutting down a process to inspect a pipe costs production time. What is stopping a plant manager from just running a pump until it catastrophically fails to save on downtime?
Well, the standard eliminates that run-to-failure mentality by requiring proactive, documented action. The employer must establish and implement written procedures to maintain the ongoing integrity of process equipment.
There's that word written again.
Always. They must train each employee involved in maintaining that equipment in an overview of the process and its hazards, and in the procedures applicable to the employee's job tasks. Furthermore, they must perform rigorous inspections and tests on process equipment.
Okay.
And those inspections and tests must follow recognized and generally accepted good engineering practices.
There's our friend Ragged GP again.
Exactly. You can't just visually look at a pipe and say, yeah, it looks fine to me. You have to use scientific testing. The frequency of inspections and tests must be consistent with applicable manufacturer's recommendations and good engineering practices, or more frequently, if determined necessary, by prior operating experience.
And I'm guessing you have to document all of this.
Every bit of it. You must document each inspection and test, identifying the date, the name of the person performing it, the serial number or identifier of the equipment, a description of the inspection, and the results.
And what if you find something wrong?
If you find a deficiency, say, an ultrasonic thickness test reveals a pressure vessel wall has thinned beyond acceptable engineering limits due to corrosion, you must correct it before further use, or in a safe and timely manner when necessary means are taken to assure safe operation. You cannot legally ignore a failing component.
It's all about catching the degradation before it becomes a catastrophic failure.
Now, part of maintenance often involves cutting, welding, or grinding to replace those failing parts. And that brings us to Element 9, Hot Work Permit, found in 1910.119K. Let me ask you, out of all the possible safe work practices out there, confined, space entry, line breaking, lockout, tagout, why does hot work get its own standalone element out of the 14? Why doesn't it just live buried under the general safe work practices of Element 4?
It gets its own element because of the statistical reality of chemical process incidents.
Statistics.
Yeah. Introducing an ignition source, a welding arc, a grinding spark, a localized heat source into a facility whose primary purpose is to hold highly hazardous, flammable, or explosive chemicals is one of the absolute highest risk, non-routine operations you can perform.
I mean, that makes sense. Spark meets gas.
OSHA recognized this extreme risk profile. Historically, so many catastrophic explosions were triggered by a maintenance worker striking an arc in a flammable atmosphere. OSHA elevated it to a standalone element to ensure it receives undivided systemic attention. It's the literal spark that causes the explosion. So what are the specific requirements to manage this extreme risk?
The employer must issue a hot work permit for hot work operations conducted on or near a covered process. The permit must formally document that the fire prevention and protection requirements in 29 CFR 1910.252A have been implemented prior to beginning the hot work operations.
So what does that actually look like in the field?
This often means testing the atmosphere for combustible gases with a sniffer and establishing a dedicated fire watch.
Someone just standing there with a fire extinguisher.
Essentially, yes. The permit must indicate the date or dates authorized for the hot work and identify the specific object on which the hot work is to be performed. And crucially, for auditing purposes, the permit must be kept on file until completion of the hot work operations.
It's forcing a deliberate administrative pause. You cannot just walk out into the unit and strike an arc welder because a pipe is leaking and you want to patch it quickly. You have to stop, assess the explosive atmosphere, implement fire watches, sign the permit, and document the safety measures.
It replaces complacency with a rigorous procedural barrier.
Okay, moving forward. Plants are not static environments. New technology comes out, better catalysts are discovered, production demands change, or maybe a supplier just stops making a specific valve. When you need to change the process, you hit Element 10, Management of Change, or MOC, under 1910.11(L). I like to think of MOC as the facility's immune system.
That's a compelling analogy.
Yeah.
How do you see that immune response functioning in a chemical plant?
Well, when you introduce a foreign body into a human, say a virus or even a transplant organ, the immune system has to recognize it, evaluate the threat, and adapt to handle it so the body doesn't shut down.
Right.
In a chemical plant, the foreign body is any change in process chemicals, technology, equipment, or facilities. If you just inject that change into the plant without thinking like swapping a 2-inch pipe for a 4-inch pipe because the 4-inch was on sale that day, the system might have a catastrophic reaction downstream.
Yeah, absolutely.
The pressure dynamics change, a downstream vessel gets overwhelmed, and it bursts. The MOC process forces the facility to recognize the change, evaluate the risk it poses to the entire systemic body, and update the facility's DNA, the process safety information, and the playbook, the operating procedures to handle it safely.
That is an excellent way to visualize the systemic impact of change. However, OSHA does recognize the need for practicality here. The standard explicitly excludes replacements in kind from MOC.
Replacements in kind. Okay, so if I'm a maintenance manager and a specific pump impeller breaks and I replace it with the exact same make, model, and metallurgical specification from the same manufacturer, I don't have to write a 50-page management of change document.
Correct. That is a replacement in kind. That's just routine maintenance, no MOC required.
Okay, phew.
But, and this is where companies get into massive trouble if you change anything else, it triggers an MOC. If you change the metallurgy of that impeller to save a few bucks, or change the set point of a critical alarm, or alter the concentration of a reactant, you must establish and implement written MOC procedures.
Even just changing the metal type.
Yes, because that cheaper metal might corrode in 3 days under the specific acidic conditions of your process.
And what do those MOC procedures have to address before the change can physically happen in the field?
The MOC procedure must assure that the following considerations are addressed prior to any change: the technical basis for the proposed change, the impact of the change on safety and health, modifications to operating procedures, the necessary time period for the change, and authorization requirements for the proposed change.
And the operators have to know about it.
Yes. Employees involved in operating a process and maintenance or contract employees whose job task will be affected by a change in the process must be informed of and trained in the change prior to startup.
And as we mentioned earlier, any process change must trigger updates in the process safety information and operating procedures, and often requires a pre-startup safety review before restarting. It's an entirely interconnected web.
It really is.
But look, even with perfect MOCs, robust PHAs, and flawless PSSRs, things are operated by humans and things sometimes slip through the cracks. Incidents happen. Which brings us to Element 11, Incident Investigation, 1910.119 meters.
Element 11 is all about institutional learning and learning from experience. It mandates the process of reporting, tracking, and investigating incidents and near misses. The standard requires employers to investigate each incident which resulted in, or could reasonably have resulted in, a catastrophic release of highly hazardous chemicals in the workplace.
I really want to emphasize the could reasonably have resulted in part of that sentence for you listening. That is the definition of a near miss. If a crane operator drops a 2-ton steel beam and it misses a pressurized chlorine tank by 6 inches, you didn't have a chemical release.
Right.
No one got hurt. But you must investigate it with the exact same rigor as if that beam had sheared the main valve off and gassed the facility.
That is a vital point. Near misses are free lessons, provided you actually investigate them. The investigation must be initiated as promptly as possible, but legally not later than 48 hours following the incident.
48 hours, that's quick.
It has to be. Memories fade, evidence gets moved. An investigation team must be established, consisting of at least one person knowledgeable in the process involved, including a contract employee, if the incident involved the work of a contractor, and other persons with appropriate knowledge and experience to thoroughly investigate and analyze the incident.
And what is the tangible output? What are they producing at the end of this investigation?
They must produce a formal report that includes the date of the incident, the date the investigation began, a thorough description of the incident, the factors that contributed to the incident, specifically the root causes, and any recommendations resulting from the investigation.
And then what?
The employer must establish a system to promptly address and resolve the incident report findings and recommendations, documenting resolutions and corrective actions. And critically, the report must be reviewed with all affected personnel whose job tasks are relevant to the incident findings.
So it's about evaluating trends and communicating lessons learned across the workforce. And I want to emphasize something paramount for everyone listening, especially for the exam and your real-world practice. A true incident investigation is never about assigning blame.
Never.
If your investigation report concludes with operator error, operator was fired, you have failed fundamentally as a safety professional. You haven't found the root cause, you found the proximate cause. Why did the operator make the error?
Well, let's take that a step further and apply the 5 whys methodology. Let's say the proximate cause is that the operator turned the wrong valve, causing an overpressurization.
Okay.
Why? Because the operator was exhausted and fell asleep at the panel. Why? Because they were working their 3rd double shift in a row.
Oh.
Because the plant manager refused to approve overtime for relief operators. Why? Because corporate mandated a 20% cut in operating budgets.
Wow.
So the root cause isn't the operator. The root cause is a systemic failure in fatigue management and corporate resourcing. Incident investigation is about finding the flaw in the system, not finding a convenient scapegoat to fire.
It's worse than that, actually. A blame culture drives reporting underground. If people are afraid of being fired for making an honest mistake, they will hide near misses. They won't report that the beam almost hit the chlorine tank, and you will lose your most valuable leading indicators of a future catastrophe. You will be flying blind until the tank actually ruptures.
Exactly.
Now, what happens when the catastrophe actually occurs despite all our efforts? That leads us to element 12, emergency planning and response, 1910.119N.
Because even with the first 11 elements functioning perfectly, you must plan for the absolute worst-case scenario. You can't just cross your fingers and hope your hazard controls hold up against a Category 5 hurricane, a massive power grid failure, or an unpredictable catastrophic rupture.
Hope is not a strategy.
It isn't. The employer must establish and implement an emergency action plan for the entire plant in accordance with the provisions of 29 CFR 1910.38. In addition, the emergency action plan must include procedures for handling small releases. Employers covered under this standard may also be subject to the hazardous waste and emergency response provisions contained in 29 CFR 1910.120, commonly known as ASWOPR.
So this element touches on the grim necessity of having plans for possible emergencies, defining exactly who takes what actions, securing the physical resources like chemical spill kits, self-contained breathing apparatuses or SCBAs, and high-volume fire monitors to execute those plans.
And practice drills.
Yes, conducting practice drills so muscle memory takes over during the panic. But it's also about knowing exactly how to communicate with external stakeholders. If toxic cloud of ammonia is drifting toward a neighboring residential subdivision or an elementary school, your plan better dictate exactly who calls the fire department, who coordinates with emergency management, and who sounds the community sirens.
It is the ultimate mitigation strategy. You engineer and prevent everything you possibly can with the first 11 elements, but you prepare rigorously and unflinchingly for what you couldn't prevent.
We are rounding the corner into the final stretch of the standard here. We've built the system, managed the changes, and planned for emergencies. Let's look at verification in element 13, compliance audits, 1910.110. So what does this all mean?
Good question.
It means that all these rules, all these massive binders of PSI, all these MOC procedures are completely useless if no one ever checks to see if they're actually being followed in the field.
Verification is the engine of continuous improvement. You cannot manage what you do not measure. The standard requires that employers certify they have evaluated compliance with the provisions of this entire PSM section at least every 3 years.
Every 3 years?
Yes. The goal is to verify that the procedures and practices developed under the standard are adequate and are actually being followed by the workforce.
And who conducts this audit? Can the plant manager just walk around with a clipboard for an afternoon and check off a few boxes?
Not at all. The compliance audit must be conducted by at least one person knowledgeable in the process. Often, companies will bring in external auditors or engineers from a sister plant to ensure objectivity.
That makes sense. Keep it objective.
A detailed report of the findings of the audit must be developed. And just like the incident investigation, you can't just write a report highlighting all your plant's flaws and ignore it. The employer must promptly determine and document an appropriate response to each of the findings of the compliance audit and document that deficiencies have been corrected.
Do they have to keep the audits on file?
Yes. Furthermore, employers must retain the 2 most recent compliance audit reports.
Which means you are retaining at least 6 years of audit history, which gives an OSHA inspector, if they show up at your gate, a very clear historical window into your facility's safety culture and compliance trajectory. Are you actually fixing the problems, or are the same deficiencies showing up on every audit?
Exactly. It shows your true culture.
And finally, we arrive at the 14th and final element, element 14, trade secrets, 1910.11 mine BQs.
I have to admit, when I first started studying the PSM standard years ago, I was completely confused by this element. Trade secrets. How does corporate espionage factor into a life safety regulation?
It's a very perceptive point, and it speaks to the unique nature of the chemical manufacturing industry. In this industry, proprietary formulas, specific catalyst mixtures, and precise operating temperatures are the competitive lifeblood of a company. It's their intellectual property.
Sure, Coca-Cola has their secret recipe, chemical plants have theirs.
Exactly. Historically, before this standard, some companies might try to withhold certain chemical information from safety analyses, from contractors, or even from their own operators, citing trade secrets. They didn't want the formula getting out.
Oh, wow.
Yeah. OSHA introduced element 14 to definitively end that dangerous practice.
So this element legally forces companies to prioritize human safety over corporate secrecy and profit, without question. Employers must make all information necessary to comply with the section available to those persons responsible for compiling the process safety information, those assisting in the development of the process hazard analysis, those responsible for developing the operating procedures, and those involved in incident investigations, emergency planning and response, and compliance audits.
Regardless of secrecy.
And they must do this without regard to the possible trade secret status of such information.
So if I am leading a HSRP team, and we need to know the exact chemical composition of a proprietary, highly guarded solvent to determine if it will react explosively with a newly proposed piping material, the company legally has to give the team the formula.
They absolutely do.
They cannot hide behind it's a proprietary trade secret when a worker's life or a catastrophic community release is on the line.
That is correct. The standard does offer a small compromise, though. It allows employers to require confidentiality agreements for the persons receiving the trade secret information to prevent them from selling it to a competitor.
Okay, that's fair.
But the fundamental flow of safety-critical information cannot be impeded for any reason. Safety unequivocally trumps secrecy.
Wow, okay. We have just completed a monumental, incredibly detailed journey through the 14 elements of the OSHA 1910.119 Process Safety Management Framework. For everyone listening, mastering these 14 elements from the bottom-up reality checks of employee participation to the absolute transparency required by trade secrets, from understanding the DNA of process safety information to the rigorous stress testing of PHAs and the systemic immune responsive management of change is the absolute key to passing the ASP exam for process safety.
It really is the core of it all.
More importantly, understanding the why behind these rules is the key to running a facility that protects its workers and doesn't make the national evening news for all the wrong reasons.
Before we close, I want to pose something provocative for everyone to consider as they study. Look deeply at the 14 OSHA elements we just discussed. They are rigorously detailed, legally binding, and mechanically focused. but they are entirely focused on what the employer must do, largely within the physical fence line of the facility, defined by legal mandates.
Right, inside the fence line.
But what about the underlying culture of the workforce? You can mandate that an operator signs a training roster, but can you legally mandate that they actually care about safety? What about the community living just outside the fence line who blindly trust that facility to operate safely every single day? Think about the conceptual gaps in this strictly legal framework.
And that provocative thought is exactly why we will be back. Next time on QHSE Talks, we're going to dive into the CCPS 20-element framework for risk-based process safety. It takes these 14 foundational OSHA elements and adds critical modern concepts like process safety culture and stakeholder outreach to fill those exact gaps you just mentioned.
It's going to be a great discussion.
It is. But for today, thank you for joining us for this QHSE Talks. Good luck studying, good luck on your ASP exam preparation, and above all, stay safe out there.